Welcome to the video for completing the square part 2. In this video we're going to try to solve quadratic equations by completing the square where the leading coefficient of x is not 1. So we're going to be looking at solving ax squared plus bx plus c equal to 0 when the a value does not equal 1. In the last video we only solved quadratics by completing the square where a was 1. So let's take a look at an example together. If I'm trying to solve 3x squared minus 12x plus 16 and I want to know the x values that make that 0, I might first see if I can factor it, but I can't pull out any GCF, and just to save time, we're not going to be able to factor this by grouping. So what I'm going to try to do is solve this by completing the square. Now, if you have an a value that is not 1, you need to make it 1. So your first step is to get a quadratic where you have the form x squared plus bx plus c equal to 0, meaning you're going to have to make that coefficient 1. So what you have to do is kind of force everything to be divided by 3 on all sides of the equations. So if I do that, I'm going to end up with just plain old x squared, which is good news, that's what I need. And then negative 12 is divisible by 3, I get just negative 4x. However, 16 over 3, I am stuck with that improper fraction. 16 is not divisible by 3 and I can't reduce it, and 0 divided by 3 is just 0. So I've done my job. My first step now looks like this. Granted, my c value is ugly, but nonetheless it's done. Second step. Pretty much from here on out I'm doing the same exact thing that we already did. So now I just have to get x squared plus bx by itself, and then the number on the other side, right? So essentially I'm going to do is subtract 16 over 3 from both sides, and I'm going to be left with x squared minus 4, and I'm going to leave some room here, equal to negative 16 over 3. As you might be guessing, this third step is to complete the square. Recall, to complete the square you have to take the b value, cut it in half, square it, and make sure you add it to both sides. So in this case my b value, oops, I forgot to write the x there, didn't I? My b value is negative 4. So if I were going to do the b value cut in half and squared, it's really the same as negative 2 squared, which is positive 4. I'm going to have to add a 4 to both sides. Remember, you have to add that perfect square number to both sides in order to keep this a balanced equation. What we now have, guys, is a perfect square trinomial that I can factor into just x minus the b value cut in half squared. In this case it'll be x minus 2 squared. And over here I have to get a common denominator, so I'd have to multiply the 4 over 1 by 3 over 3. That's going to be, let's just do a little side note over here, negative 16 thirds plus 4 times 3 would be 12 thirds. Negative 16 plus 12 is negative 4. So I'd really have negative 4 thirds in that particular instance. Oops, let's get rid of that mark. Let's see if I can still squeeze this in the same screen. From here, I have x minus 2 quantity squared equals negative 4 thirds. Recall, what you do here is now solved by taking square roots. I'm going to square root both sides. And this is interesting because when I square root the left, I just get x minus 2. When I square root the right, I have a negative inside of the radical, so I have to poke an I out. So I'm going to have I, and then I have the square root of 4 over, oops, that's a really ugly looking 4. Let's see if I can try that again. The square root of 4 over the square root of 3, and that becomes x minus 2 equals 2i over 3. You know what I forgot this whole time? When I square root, I should have a plus or minus in front, shouldn't I? So Let me see if I can squeeze in a plus or minus there. And I'm totally out of room. I'm going to have to go to the next slide. So I had x minus 2 equals plus or minus 2I over the square root of 3. This is a fun one to simplify. I have to add 2 to both sides. Now I have x by itself equal to 2 plus or minus 2I over the square root of 3. The problem is I still have a root in the denominator, so I need to rationalize this guy by doing root 3 over root 3 to both sides. Now I have x equals 2 plus or minus 2I square roots of 3 over root 3 times root 3 just becomes positive 3. And that is an ugly imaginary looking solution, but nonetheless that is our solution. Let's do another application of completing the square, and what we're going to do in this example is we're going to try to rewrite a quadratic in vertex form. So we're going to rewrite from standard form into vertex form. So in this example, let's call this example 2, I'm going to rewrite y equals x squared plus 3x plus 3 in vertex form. Alright, well, what we're going to do is complete the square. So to do this, we need to complete the square. Now, there's a couple ways of doing this. I'm going to try to make this very, very similar to the process we used when we were solving by completing the square. And if you remember, the first step is to make sure your leading coefficient is 1. Now, that x squared coefficient is already 1, so I'm taken care of. The next step is to make sure you just have x squared plus bx, or in this case, 3x by itself. So what I'm going to do is subtract 3 from both sides. So on the left, I'm going to really have y minus 3, and on the right, the 3 minus 3 cancel, and I have y minus 3 equals x squared plus 3x. It's at this stage I'm ready to complete the square. The same way I did before, I take the b value, 3, cut it in half, and square it, and that's my perfect square number, 9 over 4. And I have to add that to both sides. So very similar to what we did before. I'm going to add 9/4 to both sides. Here I have to, on the left, do negative 3 plus 9/4. Let's do this on the side here. If I have negative 3 over 1 plus 9 over 4, I have to get a common denominator of 4, so I have to multiply this guy by 4 over 4. That's really negative 12/4 plus 9/4. That almost looks like a 4 itself. That's a 9/4. Negative 12 plus 9 is negative 3/4. So at the end of the day, I have y minus 3/4 on the left. And on this side, I have a factorable perfect square trinomial, which is simply going to factor into x plus the b value, 3 cut in half, quantity squared. And if you think about it, we're one step away. I don't want what y minus 3/4 equals. I want to get just y equals. So I'm going to, if you don't mind, I'm going to erase this and get it out of the way, some of that work. I need to add 3/4 to both sides. And I end up with y equals the quantity x plus 3 over 2 squared plus 3/4. That is vertex form. As a matter of fact, I can look at that and just tell what the vertex is, and I will ask you to tell me on a quiz or a test. The vertex has the h value of negative 3 over 2. Remember, use the opposite sign of what you see with x in the parentheses, and the y coordinate being just that k value 3/4. So here's my final solution here. I've rewrote this guy in vertex form. I'm going to do one more example, a little bit more challenging. We're going to do the same exact thing. Oops. We're going to do the same exact thing, and let's, example 3, I want to write y equals 3x squared minus 5x plus 2 in vertex form. So let's write in vertex form, and this one you can see it's kind of like the first example where my leading coefficient is not nice. It's not 1. So what I need to do is make it nice by dividing everything by 3. And I made this example lots of fun. As you can see, none of this simplifies very nicely. So on the left, I have y over 3 equals 3's cancel, and I get just x squared minus 5/3 x plus 2/3. Alright, well, first step is done. At least I got my 1x squared. Now what I want to do is make room for completing the square. So I'm going to subtract that, I'm going to subtract that 2/3 from both sides, leaving on the right what I want, the x squared minus 5 over 3x. And on the left, I'm going to have y over 3 minus 2/3. And I'm going to just leave that as is for right now. Now I need to complete the square. This is interesting. My b value, let's write it over here, my b value is negative 5 over 3. So normally we'd just do the b value, negative 5/3, cut in half, and square. Guys, this is a complex fraction. Rather than dividing by 2, if you have a fraction for a b value, it's probably a lot easier to just multiply by the reciprocal of 2, which is a half. So rather than doing that, let's do it like this. Let's do negative 5/3 multiplied by the reciprocal of 2, 1/2. Remember, this is the same as dividing by 2, and we're going to square it. Multiply top to top, bottom to bottom. This is going to be negative 5 over 6 squared, which will be a positive 25 over 36. That is my perfect square number that I'm going to add. So I'm going to add 25 over 36 to both sides. Add 25 over 36. Oops, that's not a mark I wanted to make. Now, over here on the left, let's try to be organized. We have y over 3 minus 2 over 3 plus 25 out of 36 equals this perfect square trinomial, which I know can be factored into the quantity x. Now remember, the b value cut in half turned out to be that guy right there. So it's just going to be minus 5 over 6 quantity squared is what it factors into. What I need to do here is get a common denominator and maybe add these guys up. 3 does go into 36 12 times, so I'm going to have to multiply the top by 12, the bottom by 12. That's supposed to be a 12. So I have y over 3. I'm not going to worry about the y over 3. 2 times 12 will make negative 24 over 36 plus 25 over 36. Negative 24 plus 25, really, at the end of the day, I have y over 3 plus 1 over 36 equals my x minus 5/6 squared. And we're only a couple steps away. I know this seems tremendously hard, and it is. It's challenging. It's not easy. I have to get the y over 3 by itself, so I'm going to subtract. So if I have y over 3, I'm going to subtract 1/36 from both sides, giving me y over 3 equals x minus 5 out of 6 squared. And then I subtracted 1/36 from both sides. Whew, my last step. I don't want what y over 3 equals. I want to just get y equals, so I'm going to multiply everything in the entire equation by 3. On the left, if I do that, I get y equals. The 3 on the right I have to distribute to both terms. When I distribute it to that binomial, I'm just going to put the 3 in front and write it as 3 times the quantity x minus 5 over 6 squared. Keep in mind, this is my a value in vertex form. And then if I distribute 3 times negative 1, 36, that's going to be negative 3 out of 36, which I believe reduces to negative 1 12th. So this is our vertex form, our vertex being positive 5 sixths and not positive, but negative 1 12th. That would be the hardest I would ever dream of giving you. If you followed that and understood it, doing some easier ones shouldn't be too scary. By the way, easy to double check. At least make sure that your A value, 3, matches the original A value, which was 3 in the beginning. That's a quick thing to just double check to make sure you did it right. We'll see you guys tomorrow, and we'll practice a couple more of these in class. Thanks for watching.